This PowerPoint is going to give you some general math tips. Whenever you do a math problem, you shouldn't just grab your calculator first. You need to think about what you're going to do. You need to plan a strategy. And you need to make sure that you've brushed up on the algebra that you may have forgotten if you haven't used it in a while. In brushing up on your basic algebra, you really need to concentrate on cross-multiplying. Cross-multiplying is a very common trick. I cannot stress this enough. I like this slide because it color codes the two different diagonals that you would cross-multiply. On the left-hand side, you have 12 over x, and on the right-hand side, you have 30 over 75. To cross-multiply, you go on a diagonal from top to bottom or bottom to top. So 12 times 75 is equal to x times 30. So you can see here that they wrote the 30 times x on the left-hand side and the 12 times 75 on the right-hand side. It doesn't really matter which side you write them on, as long as you write one diagonal on one side of the equal sign and the other diagonal on the other side of the equal sign. So if we have 30 times x, that would be 30x on the left-hand side. 12 times 75 is 900, and that's on the right-hand side. And these two things are equal to each other. And you need to solve for x. So you need to get x by itself. So what you need to do is you need to divide both sides by 30. If you divide 30x by 30, you're just left with x. If you divide 900 by 30, you get 30. So therefore, the answer would be x equals 30. Here is another example. 4 over 5 equals x over 30. So doing the diagonal, 4 times 30 equals 5 times x. So on the left-hand side, we have 4 times 30, which is 120. And on the right-hand side, 5 times x, or 5x. We need to get x by itself. And to do that, we need to divide both sides by 5. If you divide 120 by 5, you get 124. If you divide 5x by 5, you get x by itself. A second helpful hint is to always check your units. I cannot stress this enough. The reason why we're sticklers for units is because they can help you to pick up if you make a silly mistake. For example, if a formula asks for something in meters, and in the problem you are given that value in centimeters, well, you need to convert the centimeters into meters. If the units are supposed to cancel, and when you do the problem, if they don't cancel, you should go back and check. And if your units come out wrong, your answer won't make sense. More on that later. So for example, in the first example here, if you need to put something in meters and you're given in centimeters and you put in the wrong units, your answer won't make sense. You might get a distance that's way too big or way too small. So don't just trust your calculator to spit out a number. Always look at the number to make sure that it makes sense. To figure out which formula you need to use, you need to carefully read the problem and see which of the variables you're given. So here I'm showing you all of the formulas for exam 1, as well as some unit conversions that you might be using. You can see that there are some formulas that have similar variables. For example, wavelength comes up in a number of these, and temperature comes up in a number of these, and radius comes up in a number of these. So how can you tell which formula is the right one that you need for the problem? You need to read the problem carefully. So let's take a problem like this. What is the surface temperature of a star that emits most strongly at a wavelength of 700 nanometers? So you're asked to find temperature, and you're given a wavelength. Can you see a formula that relates wavelength to temperature and has no other variables hanging out there to bother you? There's only one on the formula sheet that meets that criteria, and that's Wien's law. You can see here circled, Wien's law has the wavelength of maximum emission or strongest emission on the left-hand side. You have on the right-hand side 0.29, which is a constant. The units are centimeters times Kelvin, and that is divided by the temperature in Kelvin, so that definitely relates wavelength to Kelvin, and that would be the right formula to use. However, remember that in the problem you were given the wavelength in nanometers, and here notice that the wavelength has to be in centimeters. What do you need to do? You need to convert. What about this question? What is the radius of a star that is twice as luminous as the sun but half the temperature? So you're trying to relate radius, luminosity, and temperature. There are two different formulas here that relate those three things, both forms of the Stefan-Boltzmann law. So how do you know which one to use? Well, look at what you're trying to find. You're trying to find the radius. So if you can find a form of that formula that already has the radius by itself, isn't that going to make your work a lot easier? So I circled the one that I personally would use because you notice that radius is by itself on the left-hand side. And on the right-hand side, you have the square root of the luminosity divided by the temperature squared. Now, if you want to do a whole lot of extra work, you could use the formula to the left of that. L is r squared t to the fourth, because that's a form of the Stefan-Boltzmann law, and that does relate luminosity, radius, and temperature, but you have to do a whole lot of algebra to get the radius by itself. That's why I would prefer to be lazy and use the one that has r already by itself, the one that I've circled. Something I brought up before was, does your answer make sense? Do you expect to have a big number or a small number? If I'm asking you to calculate the distance to a star, I think you expect to have a big number. If I'm asking you to calculate, for example, the size of a wavelength of visible light, that should be a very small number. So ask yourself, does my answer make sense? Do I get what I expected to get? If you get a negative temperature, for example, is it possible to have a negative temperature? Well, not on the Kelvin scale, it's not. So always look at your answer and see if it makes sense. And one thing that you need to ask yourself honestly, and only you can answer this question, are you really practicing the math as much as you should? Now, everyone is different in terms of what they find easy and hard and what they need to practice on, but I give you plenty of opportunity in this course to practice the math. For example, do you go over the examples that we did in class? That's why I do them in class, to have examples that you can go through and see if you understand and see which steps you're having difficulty with. But you can't just look at the examples we did in class. I also post a whole slew of practice problems with solutions on Blackboard. Have you gone through those? Have you also gone into the online resource collection? Because there I have links to websites and videos. These links are called Math Minute, and you can actually hone in on just the formulas that are giving you difficulty. Do you go over the solutions to the homework after they're posted? That's why I post the solutions and not just the answers, so you can go back and see what you've done wrong. And did you come for extra help? Did you come to my office hours? Did you make an appointment to come and see me outside of office hours? You need to ask yourself, have I done all that I can to be my best own advocate and to practice the formulas as well as I could?